We're going to keep this in the archives of Berkeley National Labs. Today, we are going to talk about electric versus gas-fired appliances and how we deal with them as an institution and have a discussion. It'd be nice to hear from everybody what you guys think about it and where we're going. But this is a topic that's probably near and dear to my heart. And I got asked to be part of a county board discussion in our area because the push for electrification without recognizing some of the other costs and benefits that or pitfalls you get yourself into. So in Chicagoland area, the number one thing that destroys any vapor compression system is the swings, like everywhere. But we have very big swings in the Midwest here on temperature, and it can really pummel equipment. So I was asked to go to a county board thing, and I opted into running a test for everybody's heat pump that they want to design to do a gas-fired and electric. And now, through the gas companies, they're coming back with the old ammonia absorption chillers. So there's a lot of concepts I think that folks can talk about here to try to wrap their head around what is electric versus what's happening with gas. And the first thing that needs to be addressed, I posted some things. I worked on a building decarbonization group with GridWorks. It was put on by GridWorks. You use the term GridWorks, that means they have an interest and I think an inherent bias towards electricity and to generate that electricity. And I was consistently finding myself having the argument with folks that, are we talking about decarbonization or electrification? Because they're two separate things that folks don't address correctly. And I don't appreciate it or like it. And I think you have an ethical responsibility to look at everything from an unbiased perspective and look at the realities of the energy. So with that being said, what's interesting to me when I talk to students, and I'm going to open it up for discussion here, but I'd like to pave a pathway here to get folks to understand it, is I've heard a lot of stuff all day about building decarbonization and how we're going to work on breaker boxes. And nobody's talking about transmission, distribution, and transformer capacities and the infrastructure that exists in a grid system and efficiency. We just hear a word efficiency used that's painted that has nothing to do with reality. And the reality is that when 48% of California electricity is generated by natural gas, and to remove natural gas from the whole picture completely, saying electrification, that means we're giving the responsibility of generation and efficiency of natural gas over to the power companies. Now, when power companies generate by natural gas at 33 to 43% efficiencies, and if they're co-generating, they can get to 60% efficiency. Now we're transmitting across lines the same energy that we initially transmitted to people's homes to burn at 95% efficiency. So now we're taking this huge efficiency loss by using natural gas to generate at these powers. And in Chicago, we have Oak Park area that went straight electrification for moving into the future. In Evanston, the place where Northwestern sits, where people should have a responsibility in the city of Chicago to tell people things. And I wrote an article about this concept of, electrification and gas versus electric appliances. And, you can make any indoor air quality argument you want, all those other things. But when it comes down to it, what students need to understand so that they're not just consumed with callbacks and problems and power and fires. There'll be fire issues, brownout issues, breaker issues, the limitations. If people aren't informed and trained properly about what you're doing when you move to electric appliances versus creating policies to move everything to electric appliances without understanding the limitations and where they sit, we're going to have a problem in education. And the skilled workforce, I think, is going to have an even bigger problem than it's already facing now. And I sat in these things with these building decarbonization people, and I said, I'll argue with any one of you anytime because I actually know how to install it. And an important thing to understand is if you can install it, you really pretty much have a reality understanding of what your limitations are and where that's at. And it's our jobs to prepare technicians with that reality so that they don't go out there confused and using buzzwords and robbing our communities of their trust in our skilled workforce to move technology forward. Make no mistake, I'm all for higher efficiencies. But again, when you take natural gas and let power companies generate power, what are we doing here? A furnace can be 90 to 95% efficient. Old ones that are outdated are 80% efficient. You mean to tell me it's more responsible to allow a power company to generate power at 33% to 43% natural gas and then transmit it across inefficient lines on a grid and then put it into people's homes? This is a bad thing to teach the youth of tomorrow. And people need to understand that reality. And that's where I'd like to open up. And I make sure that I keep it very clear to my students what this is on electric versus gas. Infrastructure, demand, and the other concept that really needs to be addressed is why in the entire industrial world do we have dual fuel fired equipment? It's to hedge energy costs. The number one thing that I have a problem with in electrification and all electric appliances is you are putting the power in the hands of people that have gamed systems year after year after year. And I shouldn't even have to say the word Enron, but that's exactly what happened in that situation. So when I look at how a homeowner has to make a choice between gas, right, and electric, to me, it's simple in Chicago. And it's irresponsible to think that heat pumps are going to outperform and be more efficient than any type of gas-fired equipment when you look at the reality of where the power actually comes from. It doesn't come from a magical well in a place. It comes from natural gas that's burning in turbines. Illinois, fortunately, has a lot of nuclear power. If this push to electrification, how I tell students, if this push of electrification is because we've discovered a new way to generate power, that's great. Then I'm for it. But until then, I'm not. And I'm completely against it. And I teach that way to my students to make sure that they understand how to inform the duty in the civil service we have to our communities and the responsibility as HVAC technicians to let those homeowners know what they're about to get themselves into. And if you look at the Federal Register that I have here on electrical generation, this Federal Register right here, kind of buried, I don't know why anybody doesn't talk about it, but the cost of electric versus natural gas per BTU is 3 to 1. In some areas, it's 5 and 6 to 1. So let's talk about social responsibility. Let's talk about the diversity of energy, and let's include a good discussion about how you teach your students. Anybody like to talk?
Sure, Bob. You knew I would.
I know.
So, it's a good point, but, Mencken said that for every complex problem, there's an answer that is clear, simple, and wrong. And the problem of transitioning away from fossil fuels and transitioning to renewables is terribly complex.
Yes, it is.
And the complexity of transitioning from horse and buggy to cars was terribly complex too. But the two things that I think that we can agree on is we can't stay where we are. We cannot, the status quo won't hold. And the second is we're going to make mistakes as we move forward. But if we don't move forward because we're afraid of making mistakes, like we did with ethanol, all of a sudden ethanol was this magic thing, but the life cycle assessment of ethanol, that ranges from like 0.78 BTUs of fossil fuel to 1.02 BTUs of fossil fuel per BTU of ethanol. So that was an issue at that time that didn't get taken. And lots of people, the real issue here is life cycle assessment. And you're talking about economics, and the economics of building out the grid, and that transition is important. But I'm just looking at how energy is produced and electricity is produced in the US right now. And fossil fuels accounts for about 60% of it. Nuclear is 18, and renewables are 21. Now, 20 years ago, there weren't very many wind turbines. Wind now constitutes 10% of the energy production in the United States. So none of these things are silver bullets. There are no silver bullets, but taken in aggregate, I think it's moving in the right direction.
Sure. The point I was making there, Robin, that I want to be absolutely clear about is that we produce electricity with natural gas. And let's just take California, because it's where this is hosted. 49% of their power comes from natural gas. If we put electric appliances in homes, they're going to use the natural gas they took out to generate power inefficiently and then send it down inefficient lines and call it efficiency. It's a lie. And that needs to be as clear as day. It's a social responsibility to the public and the people that don't understand to state that. That's what I'm saying.
How would you move forward to that? I mean, what do you see as the goal? Where would you see us in 20 years?
Well, this discussion isn't supposed to be about that. It's how do you bring in an electric conversation versus natural gas or gas-fired appliances into the classroom, and how do you teach your students about the realities that exist? I think that's important, and I think that's what needs to be stuck to here, because I mean, I've been at different policy meetings, I've been at different seminars, and telling these people that the reality doesn't exist. We have people that make policy about these things that don't even know how to screw in a light bulb. That's a problem. That's a problem in America. It's a problem across the world. What I'm saying is, how are you preparing your students to face these conversations? I get questions all the time about, should I put a heat pump in? And what I'm telling people, Robin, is we're going to do a test. And I'm going to include everybody, because just because they're using natural gas as a heat pump doesn't make them worse than the people that are using electric, that are still burning natural gas to make electric. That's the point here. We need energies, right, that can be stored, because there's always a demand. Every time somebody wants to complain, right, about energy companies being bad, and they plug their iPad in at 9 o'clock at night and have a bottle of wine to tell everybody how bad everything is, the reality is they're using the energy that they're talking about. So how do you inform your students of electric versus gas appliances?
Well, for me, it really is about the future, because my students, I think, are probably going to be still working in the field long after I'm dead. And I graduated from SUNY Canton in the automotive technology field, right? That was when capacitive discharge ignitions were the hottest thing around. And there's been a change in that. But what drives it, and where do we want to go, and what drives it? That's what I talk to my students about, because I think it's important for them to understand that it's great for you to learn how to install gas appliances, but in New York State, you won't be installing new gas appliances in 10 years, for better or for worse, whether you agree with the policy or not.
Sure. What I'm saying is, you won't be installing natural gas appliances so that natural gas can get burned way more inefficiently and then submit and pushed across power lines to these homeowners that are going to pay triple the price. That's how I explain it to students. And the Federal Register, it's documented in the Federal Register 2023 here. It's happening. It's just, how are we making this visible for the people that we work for. We are the civil servants for our communities to make sure that they're informed and going down the right road. So let's see if somebody else has a question. Rob, you look like you're attentive here. You got something to say about how you're teaching your students?
Oh, geez, you caught me. We have a really interesting dynamic here in South Louisiana, here on the North Shore. In many of the places east of Baton Rouge, there's no infrastructure to put the natural gas heating is not in place. And you'd think, what would be the natural thing for them to put in if they don't put in a gas furnace? What do you think would be the next efficient option for them?
Yep.
What rolls off the top of your head is you think a heat pump. They are not installing or pushing heat pumps. The HVAC companies here, they're putting in resistive heating.
Wow. Now that's a problem, Rob.
The heating season is like 6 days.
Right.
But that said, they dread heating season because it doubles an electric bill that's already high from the cooling season.
Yep.
Here, these people get the crap beat out of them by their electric bill year round. And that is one of the big things that when I talk about the idea of where they're wanting to get rid of gas appliances, some people, they never had a gas appliance in their house to begin with because there's no gas infrastructure. But I talked to them about, you need to be able to start having conversations about making electricity less expensive because nobody's talking about it.
Right.
Nobody's talking about making electricity affordable. They're talking about putting in government mandates to force people to use electricity, but there is absolutely no conversation on making electricity less expensive.
Looking at this sheet here, Rob, you said Louisiana, right?
Yep.
Louisiana produces 72% of their electric from natural gas. So that means you're getting, at best, probably in the 50s, 52% efficient use of natural gas burning, in that home, working towards that. That's interesting.
And there's no discussion about load reduction, house, envelope sealing.
Right.
They'll just cram a heat kit in an air handler and they're good.
Yeah.
Unless you go to Baton Rouge, my house is natural gas, and then most of the Baton Rouge area is natural gas, but they're all 80%. Hardly anybody has a 90% furnace because they run it maybe 2 weeks out of the year.
Well, and then you draw comparisons probably to your experiences in Montana, right?
Yeah, in Wyoming, you run that heat.
Wyoming,
yeah, in Wyoming, you ran that heat 9 months out of the year. And that's where you got cold climate heat pumps coming into the fold there. But at the same time, what's the price of electricity compared to the price of natural gas? Yep. And people are unwilling to convert to heat pumps if it's going to increase their power bill when they're already struggling financially.
Yeah.
But Rob, isn't it interesting that politically, environmentally, you have huge wind potential in Wyoming, and then you have a huge investment in a coal industry, and you have coal-fired power plants. What would happen if you converted most of that to wind? How would that affect the equation that Bob?
The infrastructure for wind is extremely expensive and inefficient.
Yeah, Wyoming's 79% coal as of 2022. 79% power is generated by coal, 13% by wind. So yeah, the vast majority in Wyoming happens to just be coal.
And it's a simple business choice. If you go all in with wind, you're going to lose all your business. You're going to go out of business because you can't afford to maintain it.
Sure. Yeah, and a lot of folks don't realize when they don't see the turbines, I should say windmills for but Chris isn't here, so we won't give Chris Miller a hard time. But when they're not turning for a reason, is because of all the gallons of oil that go into those gearboxes. That's a thing nobody really talks about. Again, another social responsibility to the people that you are serving civilly.
So Bob,
I challenge that, the reason that they're not turning is because of maintenance. The reason they're not turning is there's not a market. And in fact, I studied,
I didn't say that. I said they're not turning because they don't want to do the maintenance.
no, they're not turning because there's no market.
Right. This isn't, Robin, this isn't a win discussion. I understand they can't dump into the grid, and that's where FERC Order 1000 came from, is to allow it. But if you can't promise generation 24/7, there's another issue there too. I'm with you. I understand. I'm just saying there's other things that people don't understand about turbines.
Well,
Yeah,
Bob, I got my own thoughts on all this stuff. That's for sure.
Let's hear it,
What are we
Charlie.
supposed to
What
be
do you have to
talking
say?
about?
Well, I mean, I go way back, and of course, I mean, we've been in this long enough to know that nothing ever seems to make sense when they pop this stuff out there, and then you look it over and go, it just doesn't make sense. Why are you doing this? Like you're saying, efficiency is everything else. Why not burn it at 95%? Why not burn it at 80%? I mean, those are illegal almost everywhere now, around here anyways. But I go all the way back to when we were doing airtight houses back in early 2000s. And we did airtight houses and put in these systems. And I remember the first one that I did where we had a new inspector come through. And we had this, they spent all this money, super airtight house. And he says, you got to cut in two 12 by 12 fresh air intakes and put that into your return duct with dampers. And the homeowner and myself went, what? Are you kidding me? You spend all this money to make an airtight house, so you have to bring in fresh air to supply for it. It makes no sense whatsoever. And I kind of feel the same way with this natural gas electric heat thing. You know, it doesn't make any sense. Why are we doing this? Why do you go one way to get rid of one thing just to go backwards efficiency wise and spend more money doing it?
And then you got to pay to heat the outdoor air or cool it. Yeah.
Yeah, so you basically are.
How does that calculate into efficiency?
To basically, go less efficient again. I do agree with the heat pumps. I like what's happened honestly over the last like 5 years because of a lot of this stuff. You know, we're seeing these heat pumps efficiencies going up exponentially. I mean, they really are a good option for some people who didn't have a good option before. But to get rid of the gas furnace, the gas heat, the gas stoves. I mean, I run my gas stove, my gas oven. It's 100% efficient. When I kick on my oven and it goes directly into my house, I guess what? I get every BTU out of that thing into my house, and I've yet to get sick. So, they burn pretty clean. What
you're saying is you're willing to compromise a little indoor air quality for the extra efficiency. I get it.
Yeah. So I mean, I'm with you. It's a kind of a mind boggler in a lot of ways. The reasons why they do some of these things, I understand them trying to push efficiencies higher, trying to do some things, and and of course, the more they put out electric stuff, the more that technology is going to be pushed, to its limits, and it just doesn't make a lot of sense for them just to drive everybody in that direction and force them in that direction when, like you're saying, the 95%, even the 90%. Efficient systems are much more efficient, a better option for those that have that gas piping already to their house. You can't heat any more efficient than that. That's really it.
One of the big things I was bringing up with one of the gas companies around here when I told them about their ammonia gas fired heat pump that they wanted to compete with other heat pumps with, they're just bringing that technology back. There was a lot of problems there too. However, what was interesting about it is when I was telling our county board, I said, what are they going to have to pay technicians in addition to what they already pay now to defrost that piece of equipment outside and get all the snow away from it just so that they can work on it? How much more time is that going to take? And that's why everybody's going for, well, we're having redundancy. So what this will also perpetuate, the heat pump concept, is that backup electric heat is really the same scenario that Rob's in down in Louisiana. Or, yeah, in that corridor there, where they're putting in, and that becomes like the mainstay to solve the problem of, because we know everybody pulls vacuums on vapor compression equipment and installs it properly. What happens in the middle of a winter,
Yeah. No,
So I think there's a couple points that would be good to review. And hi, I'm Scott. I just tuned
Hey,
in
Scott.
for the conference. I'm not quite sure what the topic here is, electric versus gas. Yeah. Um, one of the main ones is homes are getting tighter. That's happening all over the country with good vapor barriers and HVAC wrapping.
state are you from,
Houses are
Scott?
getting tighter. What?
What part of the country are you from?
Madison, Wisconsin, northern
Okay.
climate, where we aren't doing heat pumps yet, but Minnesota even farther north is, and Rhode Island and Massachusetts is also doing heat pumps. Doesn't mean they're doing them exclusively, and that's the only source of energy in the house, but they're headed that way. So anyhow, back to just basic housing trends. They're getting more insulation and they're getting tighter. And if you do that, which codes are driving, you have to put in an energy recovery ventilator to get some fresh air in the house. Putting like just a hole in the wall is not a sensible way to do it, but putting in an energy recovery ventilator does make sense, and it is a safe and valuable thing to do in a tight house. You get outside air and you get some better humidity control too at the same time. So yeah, and just in general, heat pumps are becoming more established all the time, even in northern climates. There are certainly states out there that are going whole hog on heat pumps, and that they're doing okay. It's the northern climates it's most difficult to do heat pumps, because there will be some hours in the heating season where you will have to most likely rely on electric resistance backup, or if you've already got a gas system, rely on that. But it's a sensible thing to do if you're concerned about climate change. And that's the big issue.
Well, that's, a belief. So that's good. And Mattis, are you MATC then?
No, I'm a mechanical engineer, been doing energy surveys in commercial industrial buildings for the last 20 or more years.
Okay. It's good.
Hey,
But,
Peter,
stay connected to residential as well, since I live in a house.
Yeah, we all have to deal with it, right?
Yeah, just a personal note. I've got a mid-century, a 60s house with 1 inch of fiberglass insulation in the 2x4 stud wall, and it, as the energy efficiency engineer, it drives me nuts. It's like, how can I live in this house? There's 1 inch of insulation in there. It's just stupid.
It's the plumber that has the bad pipes in the house, right?
Yeah, could be.
Peter, are you still listening in?
I don't see him in here.
I'm here.
There we go.
Okay. I remember you mentioned that Wyoming uses 13% wind.
Yeah,
Yeah, I wanted to also bring in that though Wyoming is using 13%, if you have traveled out there, you should see the footprint that has. Just an absolute immense footprint. I had a huge wind farm by my house. That was one of the more southeastern wind farms that they
Is
have
that
there.
the
But
Duke Energy Farm?
yeah,
No?
we were surrounded also in western Nebraska, Panhandle, northern Colorado, all of that. A lot of wind farms on public lands there, and the footprint is just immense. Just wind turbines everywhere you look. People don't care for it because it's unsightly. It breaks up the majestic Wyoming horizon or whatever. But even though it's considered a small, that's a huge footprint, and to increase that, of course, would require a huge increase of land appropriation. And if you go just slightly, maybe 30 miles west, then the terrain no longer supports wind. Also you got another few hundred miles north, and then it becomes pretty precarious where the terrain will not. So wind's a good alternative, but at the same time, it's there's a lot of factors that limit what you can do with wind in a geographical area. But that aside, one of the big things, and of course, this is probably outdated information since I left there 5 years ago, but one of the big things that people were really getting excited about, in a negative way, there was they were all for having all this wind put in on the public lands around them, but their electrical bills went up instead of down.
So
Why was that, Rob? I mean,
I
wind,
never got into why the costs increased. I don't know if it was because the electrical company was paying for the initial investment and transferring that initial investment cost onto the customer. People were like, well, don't we get subsidies or anything like that? Now, people who put wind on their own ranch properties, they got subsidies from the government, put their own turbine in. But as far as the large public turbines, that did not reduce the energy costs for the local area, at least at the time I was there.
yeah,
It's popular in Texas and Iowa. They've got, and California.
I think there are big issues around public policy. And again, path dependency. Wyoming historically invested in coal. The utilities are happy to keep burning coal. And it's going to take a lot of energy political energy to change policies to encourage renewables. And those policies have to move together to add more electrification. And if we're not adding more renewables to the grid, then as Bob points out, it's a kind of a zero-sum game. We have to electrify and we have to build renewable energy sources. And we have to look carefully at baseload. It all has to go together.
Cost reduction has to be a huge part of it too.
Yeah.
well, storage is going to be another big issue, and particularly around solar. Where I am, where there's wind and solar, there's quite a bit of wind and solar and hydro, so we're kind of a energy colony up here in northern New York. But the advantage up here for the wind is that you can use the land for other purposes. So the average output of wind farm per acre is about 0.4 megawatts per acre, which is pretty high density energy, but you can still use that land for agriculture. So you can use it for grazing, you can use it for hay, and the big wind farms to the east of me are all on farms, and the farmers are thrilled. In fact, one farmer on the Tug Hill said, geez, yeah, I got wind turbines. He says, now I can afford to farm for another 20 years because the dairy farms don't make anything. And that's what it was subsidizing, is farming. So there's some changes. And again, it's one of these things where it's a complexity. There's a complexity of it. And you're right, Bob. There's, using natural gas to produce electricity to run a heat pump doesn't make a lot of sense now. But the point is, we're moving away from that. So there were only I think it was about 7.7 gigawatts of new natural gas power plants that were going to come online in 24, 25. But if we're going to go to other, we're going to solve that issue.
Well, another big point too is the amount of technicians needed to change out anything. If we were to go to heat pumps, it's unreal, the demand for technical educators, for technicians, for equipment, for businesses to actually produce what is happening and who we have to, make this stuff for. We can't produce it fast enough. And we're talking about millions of homes that way. The only way electrification, I see it making sense. We keep talking about these pushes, but we have to have the same conversation, same time, like the wheel and the buggies and going to the cars, is what is the new technology that's out there? Are the cold fusion things that have been populating here and there, any of that stuff coming out at all? I mean, until you have that discussion, putting a more inefficient system in, it's efficient at the homeowner, but it's inefficient for the finite energy we're worried about for our future children, right? And in between there we're calling that piece of equipment efficient and creating an agenda to move it forward. That's not socially responsible. And unless we're going to put nukes everywhere, which I'm all for, there's a great book called Power Hungry, natural end-to-end, the natural gas to nuclear. And, I don't see this concept being that strong. And with the amount that the ISOs and RTO, the independent service operators and regional transmission organizations, how they manage power and allow the deregulation of utility services to gain and profiteer from, that's a problem too. And the second you put it in the hands of people that are only concerned with profit, now we're taking utility to a whole different level.
You're exactly right about training more people to be able to, technicians to work with heat pumps. I think that you're right on there.
Yeah, it's a complicated issue. But,
Utilities Bob, utilities are a legacy industry. They've been monopolies since the early 1920s.
I call them an oligopoly, but yeah.
The public utility commissions were set up state by state to regulate these monopolies. And they're definitely a big part of the picture.
Well, when you had FERC is just an organization that was created out of the 29 crash that started with the Natural Gas Act, because the same people that were mining it were the same people that own the transmission, the same people that own the distribution, and they could just play with pricing and game the system. How do you create a true utility? I think should be the biggest question, or push first. Start with, what does it mean to be a utility? Some folks were asking, and you got to start there. Policy, again, I'm going to be real clear, and I've watched the people that make policy on energy and everything else. I've read their stuff. I'm telling you, they don't know anything about power generation. Most of them, they don't understand how the game's played. That's why Enron happened and things like that. There's so many instances. There's a place in Montana or Western Wyoming where prices are doubling overnight. St. Louis, it happened. Why are we doubling people's utility rates when this is for the greater good? It's just, so when I see agendas that move forward, really an inefficient system, if you literally compared not only a heat pump to an 80% gas furnace, I bet it's more efficient for an 80% and cost effective than that heat pump. Now, while it might be good and we move forward and, we have this idea in front of the glass, the second you look through the glass, it's another story. So I'm just saying the influence needs to students, they need to see the reality, because their businesses will depend on it. It's our communities that depend on people to say what it really is and how to be socially responsible enough to say it's not that efficient to have a heat pump if you're putting electric that's been created by natural gas at way lower efficiencies than an 80% furnace. There just doesn't make sense.
I did a rough analysis looking at that, and it takes, and I didn't add in externalities or factors that consider methane leakage from natural gas.
Well, you would have the same methane.
I get to
leakage.
finish, you talk, now it's my turn.
Go ahead.
And from coal, there is some methane leaking from coal, and coal in itself is great CO2. But you do the analysis with some numbers on COPs and efficiency on gas, standard efficiency and high efficiency. You start to break even on carbon emissions when there is 1 pound of CO2 per kilowatt hour from the power plants. And that usually means you're under 50% of your generation mix is coal. And ideally, you'd be probably around 30 or 40% to get to that 1 pound of CO2 per kilowatt hour. So it's not a terribly difficult calculation, and it does make sense if you want to look at the environmental side. I mean, to kind of think about gas versus electric and heat pumps, and the heat pump efficiency has to be, above 2.5 to make it work, with the 1 pound per kilowatt hour of CO2, 1 pound of CO2 per kilowatt hour. So it is done. People do this. People think about this, and it's not impossible. It's just a transition. Technology changes. We don't stick with the same technology for hundreds of years. We find things that we work better and upgrade them. Keep improving. I mean, that's kind of continuous improvement.
That's the hope. Yeah. That's the hope.
Well, I
Uh,
think
Scott,
that
what's your conclusion from that analysis you just did, Scott?
Yeah. To encourage utilities to be under 50% coal, and because if you're not, and if they don't have a plan to show you that they're getting there, what's the timing? Should vendors and contractors be thinking about timing? Because before that, the gas system is less carbon intensive than a heat pump with a 50% or greater coal mix. But most of the country is below that 50% coal mix.
From generation though, Scott, according to that, how power is generated, the US is on average at 18% coal.
Yeah, but there are a few states, Wyoming, Upper Midwest.
There's 2 or 3, Missouri, there's a couple, but
Yeah,
18, West Virginia is 87%, but that's their economy, and
yeah, right. So this discussion is not, only applies to a few states, like Wyoming and Wisconsin and Ohio. Texas probably, I don't know. Texas has got a lot of renewables. I'm not sure their generation mix.
So Scott, play that analysis out. If I'm below that threshold on coal, then my heat pump install is
better carbon wise than a natural gas appliance,
okay.
heating appliance. We're not talking cooking.
right. And then the real reality is, right, Scott, is who can actually install it and what transformers and grid systems actually have the power and capabilities of actually running that equipment, right?
Yeah, you gotta, well,
That's the other reality that has to be addressed, not just how much carbon, right?
yeah, I mean, for renewables, if that's what you're talking about, there are.
No, for all generations, we're talking. The reality of putting in heat pumps in everybody's home, there's a whole nother piece that goes with it.
you're talking about the demand for more electricity.
Infrastructure.
Yeah, infrastructure and talent and skill to put them in and make them work right. Yes, definitely. That's what I thought I'd hear more about in this discussion with this group, is that, yes, if you're gonna push heat pumps, you need the infrastructure and backgrounds, technically educated people to put them in and keep them working.
And one of the
more training there would be helpful.
So one of the things that I think about with that is we are talking about policy. We're talking about how we want things to go. What is it? I mean, I think we can start with the agreement that we want to reduce greenhouse gases because of the environmental difference and or degradation. If we just start there, how do we get there? So do we wait for the grid to adapt to serve a demand that isn't there yet? I mean, traditionally in this country, we tend to be demand driven in our economy. So by putting in the heat pumps and putting in the electrical appliances, it drives demand, and the utilities respond. Utilities are notoriously slow, but boy, when things start to get brownouts, they do start to get, they do move, and they do, and this is what I think why public policy is so important here. It's saying, look, this is what we expect for demand. This is what we expect of you. The New York State may subsidize some of the production and some of the transmission lines. The Power Authority just upgraded the transmission line takes energy away from the North Country and sends it down to New York City, double the capacity of one of the lines there. They had built a 765 kilovolt line in the 80s to wheel power from James Bay all the way to New York City. So those things, that for me, that's what drives it, is demand drives it. And so putting in heat pumps is what drives us to go to cleaner energy, which we're doing. So that, and you know, I'm not trying to argue, I'm just thinking about that as the point of view when you're talking about what do you tell students. I mean, I think about students particularly because they're going to suffer the consequences that are coming. And so I think
Well, I think everybody is, Robin, and let's just go back to Enron. They got fined 500 billion or 500 billion, I think, or 500 billion. And they made trillions on the taxpayer dollar. I mean, by that same method of, well, create brownouts and let's see what happens, you know, and they'll change the technology. Is that, I mean, when you think about the ethical responsibility that you have to have to the taxpayers, that's almost an insult to go that route, you know? It's a not,
I think he was
I
talking
don't
about
believe in it. So when you use the word, we think it needs to go this way,
climate
you know,
change.
I think we need to have a discussion, a real discussion of the future of, hey, how are we going to train and what are we going to train for? And how are we going to build this, you know, infrastructure that is needed first and foremost before anything?
Go ahead, Scott. You had a comment.
No, I thought Peter was good addressing higher temperatures and you know, perhaps food shortages. And I don't want to be alarmist but you know, if you get higher temperatures, which in some places is clearly happening, you know, more frequently than others, that at some point it's going to affect crops. And it's like, I don't want my kids to have to worry about that. So it's that thought is more about the future and children dealing with difficult weather situations.
Yeah, I mean, you know, Mother Earth can always have a random Yellowstone event and wipe us all out, right? I mean,
That one's not likely. That one's still kind of, you know,
right. Sure, I'm just saying, but I mean,
don't pick things to scare us that aren't likely.
right. Well, I'm saying that the speculation on what it is or what it isn't, I mean, we could debate that for hours and hours and hours and hours. And I'm not one way or another. I would rather just have a really efficient system that had a great infrastructure and was the right cost for people that work every day to make everything great for the rest of the world. You know, that's what it should be.
Yeah.
Unfortunately, there's too many other politics involved.
My take on this is that the best thing to do, as far as our students are concerned, is that we put on their radar what efficiency is, how to achieve it, have it on their mind in an educated way to be you know, understand why they should be concerned that the unit they installed is operating at the efficiency that it's supposed to be operating at, and how the best way they can achieve that. And also that impact that it's going to have, that they have on their mind. This is the reason why you pay attention to something called efficiency, which seems, I think it seems a lot of times when we deliver efficiency knowledge, it's just a buzzword, when it's best if we find ways to make students understand what efficiency is and what its impact is and how to achieve it.
Yeah. It's like if you have a condensing boiler and it doesn't condense, it's just an 80% or less boiler. What? You know?
Yeah, I was amused by that one too. You know, there was a big shift from non-condensing furnaces to condensing furnaces in the upper Midwest, and the same approach doesn't apply to boilers. But everybody, kind of all the advocates, were going, put in those boilers without knowing how the whole system worked.
There it is. That's what my dissertation was on, is systems thinking for post-secondary HVAC educators. Not enough of that. And, you know, when you look at EAR and SEER and all those other ratings, now they got another rating coming out. It's like, it's just, sitting there having discussions and actually going to test sites at manufacturers where they test these SEER and EAR rates and then looking at how they install the equipment. There's a whole nother complicated world to unravel, and solve all those problems in this one discussion.
So Bob, one thing that we can definitely agree on is we should be teaching our students to do systems thinking.
No question. Yep.
Out of all things, if we did nothing else, that would be the most important thing, that they understand the impact. My father used to say, when a polar bear sneezes, it moves the sands of the Sahara. And I tell my students that I'm a detective in search of polar bear snot, because I like how everything works together all the time. And I get paralyzed by that, by trying to figure out all those connections. And that's not good either, but I think that's better than getting stuck in a bubble where you don't understand the impact of the actions around you. So the systems thinking is, if we teach nothing else to our students, that's it.
Yeah,
I would add one more a component that I think is very important, especially for contractors and installers and all the sub-trades doing the work on buildings, is that quality control could be greatly improved in the commercial and industrial building sector. And I'm sure that applies to residential as well. But it's like, if you don't get the right controls to kind of connect it up properly so that the system works right, you don't get efficiency. So it's like, if you don't get the quality control right for the furnace or the boiler or the air handling unit or the chiller, and they don't kind of interact with each other properly, you won't get efficiency. You won't get energy efficiency gains. So I've been pushing quality control for a long time.
Yep, there's definitely that piece to it. The piece that I'll hold the line on no matter what is, what do people in our communities have to deal with? And I think that's the point I wanted to make about technicians. They have to understand the realities so they can communicate it effectively and make sure they're giving their community members the right information and not the wrong, because I can't tell you, I mean, we could just use the word lead buildings and understand energy responsibility just within that one statement, and try to say that not everything's perfect, and keeping our students grounded, to me, I think is the most important thing. And in this electric versus gas, I'm willing to go to the point where we're going to test everybody that wants to play. Bosch, Mitsubishi, this Denmark company for the absorption chillers, and we're going to see how they fire. You know? So it'll be interesting. Stay tuned. Maybe next year I'll have it all set, and we're going to record all the energy analysis on it too. And I'm linking it to a home, my house, when it turns on and off, just so it's all the same load profile with the same BTUs. So, all right, well, any other questions, comments, concerns, complex world problems that need to be solved?
Hey, Bob, I know I got here later, right? But, you know, when this bit of news came up, it made me think immediately of this session, right? You know, Berkeley, where Best Center is based,
Sure.
right? It was the first city in the nation to pass a ban on natural gas appliances in 2019, okay? And then it went into effect 2020. But recently, right, the U.S. Court of Appeals for the Ninth Circuit has said, no, Berkeley, you cannot enact this ban. Only the federal government can do it. So, you know, what I think is also worthwhile teaching students is that, as I used to tell my architecture students, you know, building is an inherently political act, right? You know,
No question.
none of this happens outside of, again, political dynamics. And while I suppose the ban doesn't force people, of course, or existing businesses to remove their natural gas appliances, then it becomes even more important for those of us who, you know, want to embrace electrification, say, okay, here are the reasons for you to do it voluntarily, right? So, but
yeah, like I had said, whatever decarbonizes more, I'm for. it doesn't matter if it's electric or gas or what it be. You know, I look at that and I try to get them to just seek that truth and whatever it is, because, you know, when you look at those natural gas generation numbers and you start thinking about its efficiencies, that's very important for them to understand. How power is generated, you know, the big system, how does it all connect? But the technician one, even the manufacturers have been hearing from, just the amount of technicians needed versus what exists currently and how much it would take to change it over it's astronomical. Maybe it'll turn into something like the Nursing Reinvestment Act in 2004, when they gave $397 million to help nurses with the big waves of retirement. Maybe this is that same type of thing, is how do we, more than Perkins, how do we fund and fuel, you know, programs across the country to kind of upscale enough to get the right technicians and for the right, you know, newer careers. But, you know, until that hits that federal level, you know, we're still going to sit right where we are now. So it's good. FERC Order 1000. Great
I
example.
don't know why it pops into my head, but there's this old stupid Jerry Lewis movie where everybody was driving around with a chicken coop on top of their car.
Wow, that brings back memories. Yeah, it's a very complicated issue. So, you know, all gas versus, you know, all electric. I don't know. I guess it depends. But I'm hoping with the all electric push is that there's new technologies on the horizon that just aren't announced yet, to cause it to be this publicized, this big public communication campaign that is out there. I hope it's for the right things, and, you know.
Is there any more conversation on the reduced grid where they would reduce a power grid to where they would have a source every city block or so?
Yeah, microgrid stuff, yeah.
Yeah, microgrid. Is there any more conversation about that?
No.
There's some experimental microgrids. There's actually one, we're working on one in Potsdam. There's a couple of small hydro plants on the river here, and then they're trying to bring in Clarkson University and the hospital into a microgrid. That was talked about. It hasn't actually happened. There's another one actually in Buffalo that with the medical campus there, ironically using an oil fire generation plant as the generator for the microgrid, but also ironic because of course here you are in Niagara Falls, the beginning of, you know, sort of the mother of hydropower. But there are all these kinds of things that are coming along, and they're very exciting. Some of my students have done some work on those. So,
And if one company pulls out, nobody wants blackouts. Nobody. So.
Well, and I think the Echo Block project, and I see Miriam is here and she may want to comment about it. The utility company is right there in the mix, and state law as well, determining whether you can have a multi participant microgrid or not. And in the case of Echo Block, you can't, because of state law and because of the position of the utility. So to get where we need to go, we've got to take on a lot of challenges. And of course, the thing we never talked about was the externality involved in carbon use. And those costs are going to be astronomical as we go forward. We haven't even talked about how they factor in. And in California, because we had fires and we had faulty electrical lines and so forth, now electrical rates are going to go up because we're going to internalize the cost of replacing lines and doing the upgrades necessary to the consumers. And it's climate driven. So it's billions of dollars in liabilities that the utility has paid. And those costs are going to be absorbed by the ratepayers ultimately. So there you have it.
More
And
trucks.
FERC, by the way, Bob, FERC did a terrible job of monitoring and regulating Enron, and it really allowed Enron to run wild.
It's terrible. It's terrible.
Yeah. So it was a failure of regulation. And of course, in our system, nobody likes, the private sector does not like regulation, right?
It just felt like the lemming theory of there was so much push for something better. They just let them right off a cliff.
Yeah.
And that's the sad part about it all. So
And Miriam did put a link in regarding EcoBlock and
So-
the challenge of sharing energy across multiple customers.
Thank you, Miriam.
yeah, you check that out.
So Kurt Vonnegut said we may be the first species to go down in history as the first society that wouldn't save itself because it wasn't cost effective. And I think it's funny. It's also partially true. And we can see this in the work on climate change at the national level, that we're all worried about what's going to happen to our country or ourselves, and our selfishness is going to sink the ship. And I hope that we can avoid this. And I think that we're all working on that. But it is the other thing that I think we need to talk to our students about, is that this is not something that happens as individuals. This is something that happens as a social movement and as people working together.
Yep, maybe the trials for Maldians will save us, right? Yeah,
Good for that, Robin. Wow.
Kurt Vonnegut is great. Well, great. I think our time's up here, and it was fun chatting with everybody. And any future comments, questions, or anything, let me know and send an email. And I think we'll call it here.
Thanks, Bob. I always feel like I learn something when we chat, and I always have fun doing it, if nothing else.
Exactly. Always good conversation. Always good conversation. Take care, everyone.
Thanks, Bob.